Now let's move on to a widely used visualization technique, the histogram. Histogram helps us understand the distribution of continuous data by splitting it into intervals and then displaying the frequency of data points in each interval. Whether you are analyzing the patterns in data or identifying outliers, histograms provide a clear picture. A histogram is basically a graphical representation of the distribution of numerical data. The data here is divided into intervals or bins, and the frequency of data points within each bin is displayed as bars. This makes histograms an excellent tool to visualize the shape of the data and understand its distribution. You can quickly see your data if it is skewed, spread out, or concentrated in a specific range. Now, when should you create a histogram? First, you can use histograms to understand the overall distribution of your data set, whether data clusters are present, what the variability is, and whether any outliers exist or not. Second, they help you identify the central tendency or the most frequent data points. Histograms are best suited for continuous or quantitative data, where you want to display the underlying distribution. Now let's look into the code block on how to create a basic histogram. To create a basic histogram, we'll use the MPG column from the empty cast dataset, and we'll add a title to the plot and the x and the y-axis label. We'll color it light blue, and we will set the breaks, that is number of bins or bars in the histogram, to 10. So two key points here. First of all, we used the hist function and we added the breaks as 10. This basic histogram will show the distribution of miles per gallon for cars in the empty cars dataset. The frequency of the cars in the different MPG ranges is visualized. For example, most cars tend to have an MPG between 15 and 25. Now let's look at a stacked histogram of MPG by cylinders. For this, we'll first of all load the libraries ggplot2 and dplyr. Next, we'll map the MPG variable on the x-axis and set the fill of the bars based on the number of cylinders. The factor CYL, cylinder, makes sure that the cylinders are treated as categories. Next, we'll create a stack histogram where the bars are stacked with the number of cylinders. Then we'll set the number of bins to 10 and add the title and the axis labels. The stacked histogram here shows how the cars with different cylinder counts are distributed across MPG ranges. For example, we can see that the cars with 8 cylinders typically have lower MPG values, while cars with 4 cylinders tend to have higher MPG. Next, let's create an overlapping histogram of MPG by cylinders. For this, we'll use the geom histogram, which will create an overlapping histogram, and we'll set some arguments here with alpha as 0.5 to allow the bars to overlap, and the position is set as identity, which will ensure that the bars for different cylinder counts are plotted on top of each other rather than stacked. This plot provides an overlapping view of the distribution of MPG for cars with different cylinder counts, and the transparency here allows us to see where the distributions overlap. The cars with 4, 6 and 8 cylinders have distinct MPG ranges, and we can observe the overlapping areas where their MPG values are similar. Now let's create a histogram with a density overlay. Here, instead of showing the raw counts, this histogram will show the density, that is the relative frequency of the data points. And then we'll add a red line that will represent the density plot, which smooths the distribution. The specific histogram shows the density distribution of MPG values, and the red density curve gives us a smoothed version of this distribution. This will allow us to visually compare the raw data histogram with the continuous probability distribution, that is the density curve. Next, let's create a cumulative histogram of MPG. For this, there are two key factors. The first one is we'll set frequency as false, which will make the y-axis represent the probability density rather than raw frequency, and we'll set cumulative as true. This option will create a cumulative histogram where each bar will represent the cumulative proportion of data points up to that bin. This cumulative histogram shows the accumulation of the cars as MPG increases. And by looking at the plot, you can determine which proportion of cars have MPG values below a certain threshold, giving insights into the overall distribution of the dataset. Next, let's create a faceted histogram by cylinders. For this, we'll use the facet trap around cell, which will separate the histogram by the number of cylinders, creating individual histograms for each cylinder category. And geom histogram will create the histogram for each category. The faceted histogram breaks down the MPG distribution for each cylinder group, be it 4, 6 or 8 cylinders, into separate panels. And this will allow an easy comparison of the MPG distributions across different cylinder groups. That was all for this session. We'll now meet in the next session where we'll discuss about heat maps. Thank you for your attention. See you in the next session.